Hi everyone. This video provides you with an overview of my work as a postdoc researcher of the INFIERI network at Thales Research and Technology. The title is Techniques for Dynamic Workload Partitioning High-Performance Heterogeneous Computing Platforms. My work consisted in applying artificial intelligence techniques in order to propose a new way of solving the problem of data partitioning of parallel applications. This figure shows the problem I'm trying to solve. Given an application J with several different kernels, we are supposed to map those kernels onto the HPC platform, which contains heterogeneous devices, like CPUs, GPUs, and FPGAs. Solving this problem is important so we can efficiently use the resource of the HPC. For example, in scenario 1, if we have already in an application J mapped, how are we supposed to map the kernels of a new application K that comes in? This way, my goal is to develop a system manager able to sense and react at runtime to variations in the high-performance heterogeneous computing platform, as well as in the QoS requirements. This takes us to the problem formulation. I chose a simple scenario. We have only one application with a single kernel and only two devices, a CPU and a GPU. Here we want to estimate the amount of data that should be allocated to each device. Here we define best partitioning as the one that enforces minimization of execution time. The design of the system manager is as follows. We have the QoS requirements, which are predefined by the user, and in our case, it is the maximum execution time of the application. And we have the profiles. The profiles store the execution time of the application in each one of the individual computational elements. Using this, the system manager performs calculations and provides the HPC platform with a partitioning of the data of the application. The HPC then starts running and feeds back its state to the profiles in order to modify this matrix R. This can be mathematically formulated as follows. We define the error EK, which measures how well the resources can be combined to achieve the QoS requirements. So we have the desired requirements stored in D, and here we have a combination of the resources as a function of the amount of data that is allocated to each device. Here is the intelligence embedded in the system manager. Using the error previously defined, we construct this cost function. So we formulate the workload partitioning as a minimization problem. To minimize this cost function, we use an artificial intelligence algorithm, an adaptive filter, specifically the reweighted least mean squares. This adaptive filter is naturally fit for real-time estimation. There is no need for previous training. Also, it is able to track variations in the HPC resources, the matrix R, and in the QoS requirements, vector D. Finally, it's easy to be scaled up towards several applications or an application with several kernels and computing devices. This is the final update rule of the filter. So using this, we are able to estimate at each time iteration a better distribution of data among the computing devices that compose the HPC platform. And here we have the results of the tests performed with that simple scenario using only one CPU and one GPU. The test is the variation of the QoS requirements. So D changes while R remains fixed. The adaptive filter is able to provide a new workload partitioning at runtime with fast reaction. We can see this in this figure. Here we have a metric called mean square error, which measures how well the adaptive filter converts in time. And here we have the partitioning, the lambda. So at the beginning, we have 50% of data in the CPU and 50% in the GPU. Then the filter starts to adapt and converts to a level of minus 50 dB, which results in a distribution of 80% of the data in the CPU and 20% in the GPU. However, at iteration 250, there is a change in the QoS requirements. This change is that I want that the application to perform better. So the filter adapts in a way to put all the data in the GPU, as you can see here. And of course, the CPU will have no data to perform calculations. Around iteration 350, there is another change in the QoS requirement. The change is that I allow for the application to perform slower. So the filter adapts again and achieves a level in which 40% of the data will be sent to the GPU and 60% will be sent to the CPU. Thanks for your attention.